We've all heard of Einstein's famous equation, E equals mc². But what does it actually mean? Why is it important? And how did it affect the world we live in today? More than 100 years ago, Einstein published this equation. Since then, it has been one of the most recognizable equations in the world, even though most people don't even understand it. Let me explain. Energy equals mass times speed of light squared. The speed of light is constant, so for understanding the equation, we can just as well remove it. We are left with energy equals mass, so that means energy actually is mass. So when are we using this? Every element consists of particles. But what if I told you that each element's particles actually have different mass? It's true. This graph represents the change in mass for each element. We are actually using this in nuclear reactors. We take uranium that is pretty high on the graph, make it hit its critical mass by hitting it with another neutron. So it collapses into krypton, barium, and free neutrons. Krypton and barium are lower on the graph, so that means their particles have lower mass. This whole difference in mass was turned into energy. These are huge amounts of energy, even though the loss in mass is actually not that high. For just 1 gram of uranium, we can get enough energy to power a 100-watt bulb for 250 years. But what stars are doing is even more fascinating. You see, the stars don't make molecules collapse to make energy. Instead, they fuse hydrogen atoms in helium. You can see on the graph what a huge difference there is between a hydrogen particle mass and helium's. Fusion is actually around 15 times more effective. So for just 1 gram of hydrogen, we can power our 100-watt bulb for almost 4,000 years. So why aren't we using fusion instead of fission? Well, let's imagine it like this. I have a Lego block here. Just for a second, imagine this block as a particle with 1 proton, 1 neutron, and 1 electron. Uranium has 119 of these, so it doesn't take a lot to make it collapse. But with fusion, it's different. Hydrogen cannot collapse because it has nothing to collapse into, but it can fuse with another hydrogen atom. It's not as simple as making them hit with enough force at the precise spot though. You see, when they do that, they become an H2 molecule. In order for them to actually fuse, they would require extremely high temperatures and pressure. And for us to achieve these conditions, we need to spend more energy than we get once the atoms fuse. Once we manage to achieve these conditions easier and with less energy, fusion will quickly replace fission, not only because it produces more energy, but it also doesn't create any radioactive material.